All right, so today is polygons and angles. How can you find the sum of the interior angles of a polygon? All right, so that's our big essential question today. So you're actually well familiar with what polygons are, and these are some examples, right? These are regular polygons. This is where it's all going to be equal side lengths. So you got an equilateral triangle, square, pentagon, hexagon. They keep going up, right? As the different shapes are going. So we're talking about polygons. These are going to be considered polygons here. And here's the definition for polygons. It's a simple closed figure, closed figure formed by three or more line segments. The segments only intersect at their endpoints. Okay, so those are the pictures that we just saw. Take a moment to write down your definition. And just as a refresher, here are some names of polygons, of regular polygons. So we have the equilateral triangle, that's 3 sides. Square has 4 sides. Pentagon, 5 sides. Hexagon is 6 sides. Heptagon, 7 sides. Octagon, 8 sides. Nonagon, 9 sides. Decagon, 10 sides. And undecagon is 11 sides. Go figure. For the most part, you're going to see, decagon and below. And then anything other than that, I'll probably just tell you how many sides it has. So we're going to figure out the interior angle sum. So you're going to take all the inside angles and add them together. Now, if you recall already, we know one of these. We know a triangle. We've talked about a triangle. If I add them all up, it's going to equal 180 degrees. That's what we've been talking about for the last few days. But now, let's see what happens when we introduce different sides of shapes. So we're going to use that whole idea of a triangle, right? Number of sides. This is a polygon, right? It's closed up. It's closed and they meet at the edges, the line segments. And I know that's one triangle, and I know that a triangle is made up of 180 degrees. So that's going to help me for the rest of my answers. Because now if I go to a 4-sided shape, okay, this doesn't have to necessarily be a perfect, regular polygon or a regular square here, if you will. It's going to be any 4-sided shape, 1, 2, 3, 4, as long as it's closed, there's no open spots, and the line segments meet at the ends right there. So if I look at this, I can draw a little line, an imaginary line right here. And I notice I have 2 triangles. I have this triangle up here, and I have this triangle down the bottom. So 2 times 180 is going to give me 360. Okay. Now if I draw a 5-sided shape, a pentagon, this is not a regular pentagon, but it's a pentagon still. It's got 1, 2, 3, 4, 5 sides. Again, I can draw imaginary lines from vertex to vertex, and I can see that I have 1 triangle, 2 triangles, and 3 triangles. So I could just go 3 times 180 and find out that the total angle measurements, if I had all the angles together, they're going to give me 540. And so here's my last one. Let's go with the hexagon. Non-regular, just a hexagon. So I'm going to go 1, 2, 3, 4, 5, 6-sided. I cut this up into triangles. Once again, I go from corner to corner, which is vertex to vertex, just like that. I notice I have 1, 2, 3, 4 triangles, and so I can go 4 times 180, which is 720. So take a moment to get this into your notes. And really what I want to get across here is take a look at, if we start with the number of sides, can we come up with the answer pretty quickly? And so we go look, let's see what happened. We go from a 4, we ended up changing it to a 2 and times it by 180. I started a 5, I changed it to a 3, and I times it by 180. A 6, I change it to a 4, times it by 180, and I get my new answer. So what's happening to each of these values, if it's going from 4 to 2 times 180, 5 to 3 times 180, 6 to 4 times 180, what's happening? Well, this is what's happening. It's a key concept. It's called the interior angle sum. The sum of the measures, okay, so adding all the interior angles, is n minus 2 times 180, where n represents the number of sides. Let's see how that applies. N is 4 in this case. We subtract 2 from it, we get 2, and times by 180, 360. N is 5 in this case. 5 minus 2 is 3 times 180. 6-sided shape. 6 minus 2 is 4 times a 180. And so we come up with basically this formula, if you will. no matter how many sides it is, you just tell me the number of sides. I subtract 2 and times it by 180. That'll tell me the total number of interior angles if you add them all up together. Let's try an example. So the sum of the measures of the interior angles of an octagon, like an octopus, has got 8 sides. And so I say, okay, so if it's 8 sides, n is 8, and then I just use my formula, right? So I plug it in, I substitute it. I go, all right, 8 minus 2, which is 6, and then times it by 180. Tells me it's 1,080 degrees. So in an octagon, all the inside angles will give you 1,080. Okay, excellent. Great, and then here's my next concept, my last concept for today, exterior angles. So we want to talk about, what about the outside of a polygon? All right, so in a polygon, the sum of the measures of the exterior angles, one at each vertex, is 360. Say what? Basically says, look, if I got, this is a pentagon, and I'm going to talk about the exterior angles now, the ones that are just outside of the polygon. So if I had to add up all these 5 angles, they're going to equal 360. And the thing is, no matter what the shape is, the exterior angles will always be 360. It doesn't change at all. Okay? So in this case, angle 1 plus angle 2, 3, 4, and 5 equal 360. If I just show you a couple more examples of this, I've got this triangle. I've got this outside angle of 140, an outside exterior angle of 100, another exterior angle of 120. If I add these 3 together, I get 360 degrees. Same is true with this 4-sided shape here. I've got 110 plus 105 plus 40 plus 105. I add all that stuff up, I get 360. Okay? Got one example for you, and that's it for your notes today. So let's try this one out. It says find the value of x. I kind of threw a little monkey wrench in here because I say, look, value of x. I can do this. I go x plus 95 because that's an exterior angle. This is an exterior angle. Plus 115, another exterior angle. Plus, I don't have this exterior angle. However, I know that this here is a straight line. And when I have straight lines, I know there's something called supplementary angles. I know that this part here plus this part should equal 180. So just to find this out, I'm going to go 180, subtract 110 from there. Subtract 110, I get 70. Okay, so I found out this outside part is 70. All right, so I have all my exterior angles. This is the one that's missing, and I know when I add them all up, I should get 360. So I'm going to take a moment to add these things up together. I'm just going to go piece by piece. I don't know the answer to this yet. Let's see, 115 plus 5 more is 120, plus another 90. That gives me 310. Wait a minute, I did something right. 210. I knew I did something wrong because I'm like, wait a minute, I can't add 70 to that. So 210. If I had 70, I'd be over my 360 already. All right, so all that equals 360. I'm going to add these together now, and I get x plus 280 equals 360. And then my last part would then be to solve the equation. Solve for the x. I subtract 280 on both sides. Those cross out. This drops down. I get x equals whatever that is subtracted, which gives me 80. All right, so now I know that I can come back over here, and I know this angle measurement is 80 degrees. All right, that's it for notes today. Remember, take a moment to make sure that your summary and questions are there so you don't have to do them later. All right, see ya.